Hi class, hopefully you're continuing to have a good day, and today we're going to be starting a new lesson, still dealing with the unit circle and exploring what is the unit circle. We will be looking at lesson 9.1.6, and kind of the main objective is to be looking at special triangles and reference angles to be able to label the exact values of the coordinates of a unit circle. Core problems are 972 through 975. And before you start out this lesson, I just want to go over how to convert degrees to radians and radians to degrees. So for converting degrees to radians, if you take x degrees, you can times it by pi over 180 degrees. The degrees will cancel out and you'll be left with x pi over 180 radians. So to do an example here, let us say we have a degree, let's say maybe 60 degrees. And we want to convert that to radians. So I'll times that by pi over 180 degrees equals 60 pi over 180 radians. However, we can simplify this more to get pi, and 60 goes into 180 3 times, so we can get pi 3 radians. And so we see that 60 degrees is the same as pi third radians. Okay, so now let's convert something from radians to degrees. Let's say we have, let's say pi 6 radians, and we want to convert it to degrees. We'll just multiply it by 180 degrees divided by pi, and we get this. The radians are going to cancel each other out, and we'll get 180 pi over 6 pi. Well, immediately we see those pi's cancel out, and we're left with 180 divided by 6, and so this then becomes 30 degrees. And so we see pi 6 is the same as 30 degrees. So just a couple of quick examples on converting radians to degrees or degrees to radians. Hopefully that will be helpful as you go through this lesson. Keep that in mind. The first kind of problem you're going to want to do is just kind of look at some of these exact values of sine and cosine and see what kind of list you might be able to create, but expressed in radians. Feel free to read the problem further in depth for more details. 793, you should be receiving a resource page. On this resource page, there are points on the circumference, and you can draw in the right triangles. And what you can do is you can label those points as radians. And so in part A, label the exact coordinates for 3 of the points shown in the first quadrant. So as you put in those points, right, recognize that that point on the circumference, it does have an exact coordinate point, and so you'll want to label those and then take those into different quadrants. Remember, the top right quadrant is known as a first quadrant, and then we have our second quadrant, third quadrant, and our fourth quadrant. If this was like an XY axis. Okay, going forward, right, you can finish filling in that resource page, and moving on to 74, you want to draw a new unit circle. Remember, unit circle has a radius of 1, and then label a point that corresponds to a rotation of pi 12ths, and put your calculator in radian mode. And we'll come back to something like that in a little bit. So if you have pi twelfths, what is something that would correspond to pi twelfths? And so for those that are unfamiliar with radian mode, your calculator has different modes. I know at different times I've said, oh, you want to check your calculator, make sure it is in the correct mode. And we've been checking to make sure it's in degree mode. Well, sometimes we deal with things in radian mode. To change that, all you have to do is hit the mode button at the top, and you'll see the highlighting, some words highlighted. If radian is not highlighted, you want to just push the arrow button down till you get to that row, highlight radian, hit enter, then you'll be in radian mode. And that will make our calculations different because once again we're dealing with a slightly different way of measuring something. So, and then you can continue on to problem 975, and just a little refresher. Reference angles, these deal with, if we take the absolute value, so here we have 51 degrees. If we take the absolute value of these other angles in quadrant 2, 3, and 4, the coordinate point would be the same as in quadrant 1. And so this 51 degrees is a reference angle for this 129 degrees, 231 degrees, and 309 degrees. So in kind of closing, some things we want to kind of keep in mind also is that as we are trying to find the coordinate points for an angle, we may be given this measurement in radians instead of degrees. And it may be a similar concept, though. We can still use SOHCAHTOA using angle theta versus a given angle in degrees. And we can still use our knowledge of special triangles to find the heights or the bases of triangles. We can also use our knowledge of using SOHCAHTOA. We recognize that we're dealing with a unit circle, so the hypotenuse will be 1. So we can use that with the SOHCAHTOA to help us find either the height or the base. Once we find one of those, we might be able to be using Pythagorean theorem to find the missing sides. So all of those will help us to determine our coordinate points and recognize that our coordinate points, one way we've looked at it is the cos of theta and sine of theta. Right? And so this is similar to x and y values in the unit circle. Hopefully this helps you get started on the lesson, and hope you continue to enjoy learning a new way to look at circles. Talk to you later.